This is the Flight Data Collector Group, and this is our Week 12 update. Over winter break, we all worked a little bit on our first blocks. We made some progress on the power supply blocks, as well as a little bit of the progress on the FPGA and NVIDIA blocks. At the end of break, we had a conversation with Don about our project. We've decided to overhaul the scope of our project and shrink it down quite a bit. Our project ended up being a little more than we could handle, so we decided to focus mainly on the FPGA and NVIDIA Jetson blocks. Those blocks in the coming days will be split into smaller blocks, and we will reassign them among our teammates. Going forward, our project is going to focus solely on either the hardware or the software aspect of the FPGA and Jetson. We haven't fully decided on what that will be yet, but our goal will basically be to make something that could later be completed into a full project. We will still have stretch goals to try and accomplish more with it, but we just need to get better under control what we have now. As the term goes on, we will hopefully be able to get a better grasp on this, and we will have something we're proud of by the end.
Hey, so this is Henry. So for this week and the last week, I did the power supply for my first draft block validation. So first, I'm using a power AC DC power adapter, so it can transfer from range about 100 volt to 240 volt into 12 volt and 6 amp. So it's about 75 watt, and that will go directly to the NVIDIA Jetson, and it's going to connect through the PCIe in the PCB and into the NVIDIA Jetson, and then I will connect the 12 volt to the LM317 voltage regulator, and then the output of that is 3.3 volt and 5 volt. So those two voltages are going to the FPGA. So I changed the resistor for the voltage regulator, and then it will change the voltage for the output. So there's a schematic for my block. So in the very left is the adapter, and then the middle one is the LM317. You can see I'm using two because I'm supplying two different voltage, and then the very right side is the PCIe. Also, the LM317, the voltage regulator can supply from 1.25 volt to 37 volt. If we need to change the voltage in the future, I can just simply change the resistor, and then we output different voltage. For the block validation document, I review some of the materials from last term because we have to write something about the project impact to the environment, and then the social, and then something like that. And then I minimize my power supply to have less negative impact to those areas. And then the cost is very reasonable. It's around $40.
So for the past few weeks, we have been working on our block validation as stated by Cadence, and my part of the blocks is the FPGA logic as well as the NVIDIA Jetson block, NVIDIA Jetson encoding block. So the FPGA parts include the SFP connectors. That is within the FPGA hardware part. Now within the logic is here with the RNA18 IP core. And so the SFP connectors is this little guy right here for optical signal to come in, and it will be going to the RNA18 IP code for further processing. And then after it has been processed, which is just gathering the data, it will be sent to a buffer for preparation to be sent through PCIe to NVIDIA Jetson. Now our ideal FPGA will be the Xilinx Kintex 7 which costs around $2,862. We don't currently have the budget for it, so we're still looking for an alternative. The SFP connectors look something like this. It's for optical signals like the RNA18 or the optical fiber internet connections. The RNA18 course looks like this with the serial data coming in and a FIFO going out. So our next step for this project is to meet with Don tomorrow to further discuss our blocks and processes because our project is quite complicated and we're going to break down some of the scope a little bit. We're going to limit our scope a little bit and break down some current 8 blocks into around 16 blocks so that we can decide which blocks to keep and which block that we can remove. And we're going to research on the applicable blocks such as the FPGA. We're going to try to find an FPGA evaluation board that comes with a PCIe interface. That way we can reduce the cost a little bit and still have the functionality we needed. And we're going to validate all of the blocks that were just created from there since all of the blocks is going to be changed a little bit. And this is the time spent per week for all of our members.